So it says, it tells us that it tells us the amount, the mass of the aluminium oxide, and what we want to know the mass of aluminium. The equation tells us if we had 2 moles of aluminium oxide, we could get 4 moles of aluminium. So 2 to 4, which would be the same as 1 to 2. So whatever amount of moles of aluminium oxide we have, we would get double that many moles of aluminium. Not that much mass, double that many moles, okay? So if we had 2 moles of that, we'd get 4 moles of that. If we had 5 moles of that, we'd get 10 moles of that. The point is the ratio is telling us that, if you get whatever, the ratio is telling us it's 1 to 2. So now to work out how many moles do we actually have, well, we've got the mass of the aluminium oxide, so we need to know the molar mass. The molar mass is up here, 102. You work that out using the periodic table. So the molar mass means the mass of 1 mole. So if we had 1 mole, it would weigh 102 grams. Now we know that because we've got 1020, we must have 10 moles, okay? So we have 10, whoops, let's try that again. That's being weird. Oh, it's because I got something else on. Okay, so we have 10 moles of Al2O3. So how many moles of aluminium would we have? Well, as I said, it's 2 to 4, 1 to 2. We worked out that. We can see that from the equation. So therefore, we should get, or not should get, maybe could get 20 moles of aluminium because the ratio is 1 to 2. So, well, 20 moles would be, 1 mole is 27 grams. So 20 moles would be 20 times that. So the mass of aluminium that we would get would be equal, we know it's 20 moles, so it's going to be equal to 20 times 27, which is 540 grams.